Hello everybody, my name is Mark, your teaching assistant for AAE451. Today we're going to talk about some OpenVSP vehicle sketchpad, and it appears that the OpenVSP official website is down when I'm recording this tutorial. So I'm not going to show you how to download and install the software. Instead, we're just going to talk about straight how to use the software. But this is the OpenVSP ground school, so you can find a lot of useful tutorials to teach you how to use the software beyond what I will cover. And then also, this is a website called OpenVSP Hangar, apparently. You can find some of the aircraft model that's already available, created by other people. And then we'll also talk about, and then for at least for commercial aircraft, Boeing, Airbus, Embraers, they have created these aircraft characteristics and aircraft planning for airport planning documents that are publicly available for you. So this is the Boeing website. You can find all of the aircraft available, including the 777X. You can also find all of the Airbus aircrafts as well. You can from A300 all the way up to the A380. So you can see that this is the Boeing 737-800 with winglets. They're also without the winglets. Also, there's the Airbus A320. So Airbus A320 Neo and CEO and all of that, you can find it in here. Also, there are a lot of performance data, environmental data, as well as maintenance, taxi, basically all of the operations related to the airport operations. If you're a general aviation pilot like me, I'm sure you're familiar with your pilot operating handbook. So this is the Cessna 172S, and you can see that from at the very beginning of the document, you can find the overall look of the aircraft. So from the side, from the top, and from the front. So these are very useful documents for you to reference if your aircraft happens to would look close to what the existing aircraft will be. So with that said, let's go ahead and start launching the OpenVSP software. So once you have downloaded, installed it, you will open this folder called OpenVSP, and then there's this item called the VSP that you just double click. It will launch your terminal, and then you will open the software. So let me half screen. I'm not going to show you how to build an aircraft from the ground up, but instead I have already created my own 737-800W over here. So I'm just going to go click on File. I'm going to hit Open. So to navigate files, you can click on these you can click on these folders, and you can click on this / to go back to the previous level. But you can also click on these bars. That's the same length as the folder name to navigate. But you can also save your current directory as your favorite. That will show over here. So we will click on the favorite, and we'll open the B737-800W. We'll accept. So this is the aircraft that I have created based on the document that I have over here. But let me go ahead and show everything, and well, let me just go ahead and walk you through from start with. So let me just go ahead and no show everything, and then I will show the fuselage. Just show the fuselage. Oh, we'll have to no show the rest. It's just like that. So this is the fuselage, and and to create a new aircraft part, you just go to the Geom browser, you click on one of these items, and if you examine fuselage, you click fuselage and you hit add, and this is what the fuselage Geom will show up. You can name your part component right here, and then the X form is allows you to translate and rotate your component over here, and then the origin, just the origin of your component in the absolute coordinate system. And also you realize that there is the relative versus absolute coordinate system that you can reference to. So since I'm using the relative coordinate system, the first column will activate, and then the second column, which is the absolute, will be hidden. So these are the symmetry panels. So you can, since this is a fuselage, there's no need to duplicate them across the XY plane, XZ plane, YZ plane. And also you have the scale factors, which is 1. I usually keep it at 1, just in case things get messy. Of course, you feel free to change this as you want, but I would rather go to the design panel or this panel to modify these parameters myself rather than relying on the scale factor. So for the mass panels, if you are now going to perform any dynamic analysis, all of that, because I don't think we're going to require you for the current stage, just know you don't have to worry about this panel unless you realize you need it. Subsection, don't worry about this for now. But design, so you can see the length. But for a fuselage, I wouldn't recommend you to actually, you can define your fuselage length right here according to the aircraft planning manuals or whatever you have defined to be. And then the tip treatment, design policy is monotonic, which means that if I add a fuselage section, which is XSEC, I will add the new fuselage section behind the one that I just created before. So fuselage section 2 will be added behind fuselage section 1. But if it's a loop, that means the last fuselage section will be connected to the first fuselage section. So this means the end will wrap around all the way to the beginning. And then free is that is different compared to the monotonic, because the fuselage X section, so fuselage section 4, so that I'm highlighting in blue, fuselage section 4, 3. So if I change this 3 from the X, the lowest I can go is up to fuselage section 2, and then the highest I can go is up to fuselage section 4. That means this is the characteristic of a monotonic design policy, but if I change it to free, I can move past the fuselage section before and after. So I can place whatever I want in this red box. And then nose cap type. So right now the beginning and the end of the fuselage have the area of 0. So you can see that the type is ellipse but has a width and a height of 0. But if it's something that is other than 0, of course you can change the fuselage cross-section type of each section as you please based on these things. But because it's an traditional aircraft, we're going to keep it as ellipse. The nose cap type currently is none because the tip of the fuselage has area of 0. But if it has an area of non-zero, that means it's a surface rather than a 3D volume. But to cap the tip or the tail, you can change these things to a flat. That means we're just going to fill out whatever the opening is out there, and then the other options you have as well. And then the test is basically the fidelity of your fidelity of your nose cap or tail cap section. And then the XX, so this is what's really interesting, is let's move the perspective. So let's talk about the perspective for now. So you have view, so you have these shortcut keys F5 to F12 to change your view sections really quickly. So 5, you can change them really quickly. So let's just go to the side views for now. And then left click and drag is rotate. And then right click and drag is pan. So let's go back and we'll pan it. And also you realize that every time we rotate, is rotating with respect to the nose of the fuselage. This is the center of the rotation. But if we want to rotate with respect to someplace else, we can just click on your keyboard R, and then the green dots will show up. You can choose the center of rotation as you please. So I'll click on this red dot, or hit left click, and it will be centered, and then your rotation will be respected to the new point. And then let's say if I just move it out of the center, I don't know where my vehicle is anymore. You just click on your keyboard C, it will bring back to the center. Okay, so let's go back to the side view, and then let's talk about fuselage section. So again, this is your cross-section number. So at the beginning it's 0, which is right at the tip, and then your section 1, which is here. So I created here for the nose of the 737. The number of U is how many nines in the U direction that you want. So if I increase in the U direction, you can see that my fidelity of the model increases. You only need the amount of nines to describe the geometry that you want, because, well, of course, the more the better, but also the more lines that you have, the more wires that you have, it's going to restrict your visibility to see through other components. And then the fore cluster and aft cluster is your preference to clustering these wires to the front or to the back of your fuselage section. And then the XYZ, of course, is to translate this translate these sections, rotation as well. And spin is interesting, is because it doesn't translate or rotate the fuselage section, but it will spin the wire along the perimeter of the fuselage cross section. So you can create some interesting shape with the spin feature, but we're gonna set it to 0 for simplicity. And again, this is where you can change the width and height of your fuselage section. My recommendation is that whenever you are working on the width, you change your view to the top view, and whenever you're working on your height, you change it to the side view of the fuselage. This brings to the next conversation. Again, I want to remind you that you can change your fuselage section over here. Let's transition to the next topic, which is skinning. Skinning is what allows me to create these convex geometries for along the fuselage section. Again, you can change. You need to select the fuselage section of your interest, and then the top side. The top is the top of the fuselage, and then the bottom is the bottom of the fuselage. You have the option to choose top and bottom symmetric, but in this case 737, it's not symmetric at this fuselage cross section, so we deselect that, but it is symmetric on the left and right side of the fuselage. So if we look at the fuselage from the top down, it's the same fuselage section, but it is symmetric from the left to the right. So that's why the left side and the right side are symmetric, and then the bottom is enabled. So let's go back to the side view. The angle is, this is the left side. This is the left side of the top fuselage section, and this controls the right side of the top fuselage section. So I give this one, so the fuselage section will approach this cross section at an angle of 25 degrees, and it has a strength of curvature of 1. And then the same thing on the right. So on the right side of the section, the angle departing the section is about 50 degrees, and then the strength is what allows me to change the kind of the focus of the curvature towards the front of the fuselage or towards the back of the fuselage, depending on how I want to set it up. We'll take a look at another example. Say back to the tail cone of the fuselage. All right, so the tail at the bottom will gently curve up. So the curvature started over here. So that is the fuselage section 2, 3, 4. And again, if you look at the top view, the left and right are symmetric, and that they don't have any curvatures either from the left side or the right side. That's why the angles is 0, the strength is 1. Same thing on the left side. But if we look back from the top to the bottom, looking from the side, we can see that the top, again, it's same as the sides, has no angle, and strength of the curvature is 1. But at the bottom, since the fuselage is starting to tilt up, right, and it's starting to tilt up on the right side of the fuselage, right side of the cross section, that's why you can see that the angle departing the fuselage section is 0, but we have a strength of 1.4. That's why you can see the curvatures, the fuselage line started to tilt up. So that's kind of the idea of the fuselage section. And then modify, I don't think you need to change this over here, but that's kind of the overall control panel of the geometry, to control the geometry of the fuselage. And then let's talk about the wing geometry. So we'll no-show the fuselage, and then we will click on the wing geometry. We'll show, and then we'll no-show the duct. So this is the wing, right? So again, you can just click on the wing in the Geom browser and then hit add. You can get a standard wing, but let's talk about this fairly complex wing geometry. So this is your wing editor in the wing geom. Again, you can change the wire of the color of the wire, and you can give a name, and then the W section is how much detail that you have for the wire. How many wire do you want to have on your W direction? And then, so the X form, again, mostly is the same as before, right? Here's your relative or absolute coordinate system. You can translate your wing using this panel, and you can rotate, and you can set your origin, and then you can attach. So you can set your plane of symmetry, right? So this is then symmetrical wing. So we will mirror this wing on the XZ direction. So I unclick, that's one wing, and I click, it's 2 wings, symmetric. And then the scale factor will keep it as 1. So this is interesting because fuselage geom, it's our parent, right? Everything we add on to the fuselage should be attached and should translate and rotate along with the fuselage. So that's why we select attach to parents to select component for translate and rotate for both of them. So you can see the end result is that if I show if I give it a show, that if I translate or rotate the fuselage, if I translate the fuselage, right, everything else moves along. Every component moves along with the fuselage. Same thing as rotation. So it changes back to 0. Okay, well, no show. And then we'll just show the duct. Show the wing and then hide the duct. And then mass again, we will kind of just ignore that for now. Same thing for the subs. And then this is plan form. So you can adjust the overall plan form of your wing. This one is, you can, if you use a simple wing, this is a good place to start with. You can just change the span or projected span. So the difference between projected span and an actual span is the span will count towards the wing. The span will count along the length along the wing, but the projected span will only count the span projected onto the XY plane. And of course, chord, obviously you know what it is, and then area, right? It calculates this automatically for you, and then and then here's your aspect ratio, automatically calculated. But when you change the area of the wing, OpenVSP will maintain the aspect ratio. Well, it's assuming that you want to maintain the aspect ratio. You just want the wing area to be bigger. So we'll come back to this one a little later, and let's move on to the section. Right, just like the fuselage section, and what you have probably familiar with from X-Flyer is that you adjust the shape of the wing by each section of the wing. Again, so this is how many panels that you have along the U direction, right? You can see that if I change this one becomes more dense, and then cluster is right how much clustering that you want to have towards this side to the root or the tip of the wing section. So we'll keep this to 1. And then selection pan form side. These are some of the wing characteristic of an aircraft. The reason why you can only select 3 out of the 8 is because if you 3 of the parameters will define the rest of the wing, and then so you can change the span, of course, and then you can change changing the span just make the wing wider, longer, right? Just like that. And then changing the root of the chord, so the chord right here, and then the tip chord right here. And then again, projected span, this as before. And then sweep angle, you can change that over here, and you can change the sweep location. So this means, so the 0, 0, the 0 right here is that means I am starting the sweep of the wing at the leading edge. The sec SW lock is secondary sweep location according to the selection over here. So so what does that mean? Let's look at the wing section number 3. Oh, actually, I can probably select over here, right? So you can see that the second wing section of the 737 has a swept angle at the leading edge, but also a swept angle at the trailing edge. So the secondary swept angle is 16 degrees, which is the trailing edge swept angle, and then I set the location of the secondary sweep at 1, meaning the sweep will occur at the trailing edge of the wing. Wing twist, obviously, I think you know what that is, right? So the wing twist is 0 degrees, so there's no wing incidence angle. And then usually we assume the location of the wing twist is quarter chord, but you can change that if you want. Of course, you can also have dihedral in your aircraft, right? So the wing section number 2 has 5 degrees of wing dihedral. And then finally, one more thing is that I would recommend you select this button, which calls rotate section tip foil to match the dihedral. So what does that mean? So if you don't select this one, you can see there's a slight change on these quote-unquote vertical lines, right? So if I unselect this, deselect this, these lines are perfectly vertical. That means the airfoil section are still perpendicular to the is still parallel to the absolute z-axis. But if I select this one, the airfoil section will rotate along with my wing dihedral or anhedral angle. This is particularly important when you start implementing wingtip airfoil geometries, right? These things have crazy high dihedrals, and if I deselect that, you can see that you will start to see that these lines become, if I deselect that for this wing section, these lines become, some of these lines become really will be placed at a bad angle for your further analysis. Say if you want to export this model to another, let's say CFD software. So I would recommend that to enable. And then what you will notice that I have this added the symmetry line of the wing. I have a wing section that practically does nothing, or that practically has no dihedral. This is because the reason why you need to implement this section is because when you select the rotate selection tip foil to match the dihedral, because it's physical, because the OpenVSP will rotate the foil sections, you will create a hollow region around here if you don't introduce a new section that deselects this and basically help these two wing sections merge together. You can experiment that yourself, try that yourself if you want, but you will basically, if you don't create a section that has this bottom disabled, you will have a gap. You will have a gap between along the symmetrical line. Okay. And then let me talk a little more about the wing tip. So again, this is where you become selecting a center of rotation will be really useful. So to create a wingtip, first of all, you need to have a section that is your wingtip, obviously. So this describes the overall geometry of your wingtip, but also you need to create a section that is the transition between your main wing and your wingtip. And oh, by the way, over here, the airfoil section, this is where you can define the airfoil of your wing. So you can choose the airfoil, choose the type. Of course, you can have 6 series or 4 series of NACA airfoils, or you can just import an airfoil file, which is called AF file, and then we will read file. And then along the favorites, there is a VSP path. If you go in here, you will find some airfoil that's already available in the software. So in this case, Boeing 737 airfoil has already been implemented right here. So this is the airfoil that I used to create the 737 wings for each section. Cancel. And then this is where you can implement your thickness to core ratio as well. Of course, this is also the place you can invert airfoil for, let's say, your horizontal stabilizer. You can just invert that. And back to the wingtip. I was saying that you need to create a transition section between your main wing and your wingtip, and by default, these things will be selected as free, and then and you can see that the transitioning is pretty jagged, right? These are harsh transitions, and this is what you won't see this on the actual aircraft. So to create these blendings is what the blending panel is useful for. This is not only useful to create blending transitions between main wing and wingtip, but it's also useful for creating blended wing body aircraft. So what this does is, let's create a better view. So let's go to F5, and then so we are looking at the cross section with airfoil section number 3, wing section number 3, which is highlighted in blue here. Let me see if I can find an even better angle. Number 7, number 8, number 9, number 10, number 11. Do I have upside up, right side up section? Never mind, I don't have one. So basically, the inboard section. So this is the settings for the inboard of the blue line, and this is the setting for the outboard of the blue line. So since we don't want to mess anything around the main wing, so we are going to change the change the blendings on the outboard of the blue line of the airfoils of the wing section. So since we're choosing, we want to, on the outboard of the blue section, we want to merge into the inboard of the leading edge trapezoid of this section, right? This region is the inboard of the next section. So we're going to select in leading edge trapezoid. So you can see that there's a smooth curve that's already generated. And then here is the outboard. So we're doing the same thing for trailing edge. So here's another nice transition. And then we'll move along to the wing section number 4. Now we're going to, since we don't want to mess up the wingtip itself, so we want to change the inboard. We want to merge this inboard to the outboard of the transition section, right? This is the outboard of the transition section. So on the inboard setting of the blue line, we will change from free to the LE trapezoid. So you can see a nicer transition occurred, and then we will also do the same thing for the trailing edge. So this is how you can create a nice transition between the main wing and the wingtip. So we'll create a more demonstration right here. So we'll swing around, right? So this looks a lot more like a 737 NG wingtip. And then finally, let's go back to the plan form and talk about the tip treatment sections, right? So now we have, if we don't have anything enabled, the tip of the wing tip is a flat surface. And again, we want to try our best to mimic the real world as much as we can. So since we don't have anything at the root, and then we only need to change the tip cap. So we will change from none to around. So this is how you can see the nice transition, right? We also enable the shading of the wing, so you can see that this is a nice looking wingtip finish. And also you can see the transition, right? The nice transition that we just created. So this of course you can change the root instance angle and tessellation control, of course clustering that we have discussed before, right? And then finally you can change the modify. So what this does is the final section of the wing geometry section is you can modify the airfoil. So delta XC. So let me change to the side profile. So the X form, which is transition along the XYZ axis, so left, right, up and down. The modify section, the delta XC is adding the X coordinate. So basically, if I have a cambered airfoil that has an instance angle, well, you know what? Let's just create some instance angle right now. Let's say a 5-degree with instance angle, something like that. And then we'll modify, and then we'll change the YC so you can see. Never mind. Basically, sorry, I haven't played with this myself before, but what this does, it allows you to translate the wing with respect to the airfoil coordinates rather than the absolute coordinate. And then the shift, and then the theta is rotating your airfoil. And then scale, of course, that's self-explanatory. Shifting the leading edge, what this does is, for some airfoils, the leading edge is not exactly at the most forefront of the airfoil coordinate. The leading edge coordinate of that of some particular airfoil is not at the 0, 0 coordinate, right? So the shift leading edge allows you to force that leading edge to the 0, 0 point of your actual coordinate system. And again, leading edge, you can set cap, right? You can have leading edge and trailing edge. You can set a cap. So for example, if my just like the wingtip, if my leading edge or trailing edge of my wing is not sharp, we can create a cap just like we did for the wingtip. Also for the platform here, for the airfoil here, which one? Sorry, give me 1 second. Anyway, so, and then one last thing is that you can have, so for example, right now the trailing edge of my wing is sharp. So we're gonna go to the wire view. You can see that my leading edge is sharp, but if I want to make it not blunt, I can change this closure to skew lower. That means along this trailing edge line, I'm adding some I'm adding some thing that goes below it. So let's say if I want to skew lower, you can see that I'm adding something below the trailing edge line. Skew upper is the opposite, and skew both is I'm adding up and adding down, and this allows me to use the trailing edge gap, right? So to create a nice rounded closure of my trailing edge. But we're not gonna do that for now. And then trimming the aircraft is you can trim the airfoil, right? You can trim the wing and you can get rid of some of the wing that you don't want, but still allows it to maintain. You can trim some of the aircraft, trim some of the trailing edge out that you don't want, or you can just trim it according to the thickness of the airfoil, right? So I'm not gonna mess around today. But that's kind of the idea. So if you apply everything that I have showed you, you can do that for the same thing for the vertical stabilizer, right? We'll show that, and then the horizontal stabilizer and vertical stabilizer. You can see that you have some dihedrals as well, right? And then we will enable the fuselage. One last thing about the wing. So let's talk about the ducts. So if you go to Geom browser, you go to duct. This is where you can allow you to create an engine, the shape of the engine itself. So we'll show that, and then we'll go to the top view. So X form, we're not going to talk about that again, right? This is an axisymmetric shape, and then we'll have and it will attach to the parrot, which is the wing, and the wing is attached to the fuselage. And then this is where you can define your XYZ location again, and the mass property sub. We're not gonna worry about that for now. And then this is, you can change the width and height of your engine inlet, engine itself, and then the shape allows you So the shape slider allows me to create this button-looking engine itself. So if I change this, right, you can see that if I'm approaching to 0, it's a perfectly elliptical shape, and then the shape slider allows me to adjust up and down where the bending will occur. So we'll go back to right, and the reason why the airfoil cross section occurs is because essentially what the duct is doing is it's treating it's revolving an airfoil around 360 degrees to create this engine nacelle geometry. And then finally, of course, you can change these airfoil settings to make the engine nacelle look a little different. So that's kind of the idea. And then finally, we will show the entire vehicle, right? So this is the 737 that I have created, and then you can use the hidden view. So right now you can see the wires of the entire aircraft structure. But one more thing about the engine nacelle is that you can rotate it, right? You can use the rotation feature to create some sort of incidence angle. Okay. Finally, we'll talk about the surfaces right here, right? So currently we're looking at the wire view of the entire aircraft. But that means you can see the inside of the geometry. So if you go to the hidden view, right, you only see the outside mode line, or outside, like the wire line that is exposed to the outside. And then the shade allows you to, if you select all, and then we'll go to shade, right? So you can, for each one, you can go to the general tab, you can choose the material, and then make your aircraft part looks a little different for each one, so it's more distinguishable. And then none is how I'm able to hide just hide the wire line. I can hide the shading of the geometry, just show the outer geometry line of the component. So that's kind of the idea. And then finally, I will show you why these aircraft characteristics for airport planning is useful. So I'm just going to take some screenshots of this document, which I have already right here. Right, so this is the same drawing that you saw just now, and we're going to go to view, window, go to background, and then we will, right now it's currently at 95% gray. This is kind of better for your eyes, but it's not very good for presentation. But if you go to image, if you select as image, and then we'll open the file. So we'll go to OpenVSP tutorial, we'll go to the site view, and we'll accept. So OpenVSP will import the image as the background of the window. So what you can do is you can scale it to make it bigger for your modeling, and then you can offset it if you like. So we'll reset to defaults. Right, we can do the same thing for the top view. We'll accept, and then what I can do is I can go to the top view shortcut, F5, and then I can use my scroll wheel to zoom up and down to match the aircraft that I'm looking for. But you can see that my scroll wheel, one notch up and one notch down, it's not going to match it perfectly. So what you can do is you can go to the view setting, and you can go to adjust. So the adjust view allows you to change your, of course, whenever you're panning, whenever you're rotating, and also the location of your center of rotation is also showed up in here, right? So let's go back to F5, and then what I can do here is that I can see the zoom toggle right here. I can change this manually as I wish. So let's go to 0.085. That's a little too big. Let's go to somewhere around the region of 155. 155. Well, how about 160? 155 was good. Right, so now, 155. Now I can match my model perfectly to the background, and then I can do the sketching, do the mold lines as I wish. But to keep in mind that the documents for airport plan and aircraft characteristics for airport planning, the sketches themselves are not always proportionally accurate, but the numbers are always proportionally accurate. So if you see a piece of measurement, always prioritize the measurement over the sketches. So that is kind of everything. Oh, one final trick is that if you look at the view setting, right, the view toggle starts at F5. What that means is from F1 to F4, these are user-defined view settings. So for example, I want to rotate this aircraft to a cool looking angle, right? and then I can press Shift F1 to save this current view into the first user-defined view setting of OpenVSP. So let's just say I rotate around again, right? I just hit F1. It takes me back to where I was. You can do the same thing for F2, F3, and F4. And then of course, you also have the different view windows. So we have been talking about one view of the window, but you can also change it to 4. Right? So there are 4 independent windows, right? That you can adjust as you like, and then the red box boundaries tells you which window that you're working on, right? And then this is really nice for screenshots and technical presentations, right? Of course, you can hide the axis toggle. You can also hide the border toggle, right? And then I can select and then take a screenshot and then change the viewport size, so basically the window size, and then I can capture the PNG, and I can save it to the folder that I like. So let's just say for view B737-800W, and we'll accept, and voila. Right, so note that it is transparent background. Of course, we can disable that, and we'll do that again. And we'll accept, and then you can see that this one has the background that we have selected, right? And remember, we can crank this knob all the way up. We can crank the other window all the way up, right? So, and then we can we'll crank this up, and then we'll crank this up, and then we'll crank this up, and then we'll hide the window again, hold the border again, and then we'll save a screenshot, and then capture PNG, and then we'll call this white background. And we'll accept. So here we have a perfectly white background, right? So this one is, you can see the background is much brighter than the one that we had before. So this one you can use for your technical presentation. So that's everything that I have to say about OpenVSP today. I know it's a lot of information. It might take a while for you to digest. So that's why I am sharing this website for you, that if you want to know more, this is all of the ins and outs of OpenVSP for you. So thank you very much, and I'll see you in the next video.